In this video, we're going to look at the foundation of reasoning. These are called conditional statements, which are known as if-then statements. In an if-then statement, you have the hypothesis, which is the part following if, and the conclusion, which is the part following then. Now, what we might have is an example, is a sentence that says something like, if the measure of angle A is 15, then angle A is acute. Well, after the part following if is the measure of angle A equals 15. That would be the hypothesis. Where then it says, then angle A is acute, the conclusion would be angle A is acute. We never write the if and the then with the hypothesis and the conclusion. Now, an if-then statement in symbols, the hypothesis has the symbol lowercase p, and the conclusion has the symbol lowercase q. So together, an if-then statement looks like this. If p, then q. This is the if-then statement. If the p, then q. Now what that means, again, is if the hypothesis, then the conclusion. Now, the truth value of a conditional is either true or false. To show that it's true, you want to show that every time the hypothesis is true, the conclusion is also true. A counterexample can help you determine whether conditional that should be true. Switch those up. Let's try that again. A counterexample can help you determine whether a conditional with a true hypothesis is true. So let's go back to that example of, if the measure of angle A equals 15, then angle A is acute. Well, can we find a counterexample or to show that this is not true? Because to show that it is false, we find one counterexample for which the hypothesis is true and the conclusion is false. Well, the hypothesis is the measure of angle A is 15. Is there any way that we can ever get, if the measure of angle A is 15, that we get an angle that is not acute? No. So our counterexample tells us that we can't find a counterexample, so we know that the truth value of this conditional is true. The negation of a statement P is the opposite of the statement, and it is written like this. The negation symbol is sort of like the part of an approximation symbol. This is read as not P. Where this is read up here is read as if P, then Q. This is read if not P. So for example, in our hypothesis, in our conditional statement, if the measure of angle A is 15, then angle A is acute. The negation of that statement would be, if the measure of angle A is not 15, then angle A is acute. Now that would be a false statement. We can use negation to write statements related to a conditional, and every conditional has 3 related conditional statements, which we will learn about in our next video.